Okay, WebAssign 11F, number 17. Consider the mass spectrometer shown schematically in the figure below. The magnitude of the electric field between the plates of the velocity selector is 2.90 times 10 to the third volts per meter, and the magnetic field in both the velocity selector and the deflection chamber has a magnitude of 0.03 teslas. Calculate the radius of the path for a singly charged ion having a mass m is equal to 2.4 times 10 to the negative 26 kilograms. So, in the mass spectrometer, so what happens is that the electric force and the magnetic force are going to be equal. Yeah. Oop. So your Fe from the unit from the electric fields is charge times the electric field, and that's equal to the electric force. Now your magnetic force is equal to the charge times velocity times magnetic field. So now what you want to do is that you want to solve for velocity, because in the problem here it says that that the charge, if you see here, it's going to go through here, the mass spectrometer, and then it's going to curve there at the end in like a circular motion over there. So you're going to see why we're going to need this in a minute. But basically, the charges cancel out. You get E is equal to VB. And what you want to do is you want to solve for velocity, E over B. And you have those parts. Your E is 2.90 times 10 to the third volts per meter. And that's over B, which was 0.03 teslas. So that means that your velocity is 9.67 times 10 to the negative fourth meters per second by plugging into your calculator. So now, again, you wonder, why did I solve for velocity? Well, I'd mentioned that the charge, it's going to move in a circular motion up there at the top. So this is centripetal force. And if you remember, centripetal force is equal to mv squared over r. Now, your centripetal force is going to be equal to the magnetic force, since it's going through the field. So your FC, your centripetal force, is going to be equal to magnetic force. So we just plug in mv squared over r is equal to, and then we already said magnetic force is, we said it was QVB. So now, you just have to basically rearrange, because what you want to find is the radius of the path. So you have m, it gives you in the problem. You have the velocity, you have the charge, and you have the magnetic field. So basically move everything to one side, and then r on the other. So by moving around, you get that r is equal to mv over qb. Now you plug in what you know. The mass, says here, is 2.40 times 10 to negative 26 kilograms. All right. Then your velocity, which we found here, is 9.67 times 10 to the negative fourth meters per second. Now your Q. It shows here that you are launching a a proton in there, singly charged ion. So the charge of that is 1.6 times 10 to the negative 19th coulombs. And your magnetic field, once again, is 0.03 Teslas. So plug that piece in the calculator to get R, and your R is 0.484 meters. And you can see that is the answer right there, number 17. So for what made this difficult, as per usual, I feel like it was the setup of the problem. Like, for one, you have to kind of have an idea of what the mass spectrometer is. So you have to know to set your, well, first off, the reason why I went off the electric force is equal to magnetic force is to find the velocity to find centripetal force. And centripetal force, it's review from what happened from what we learned last year. So that's why we had to set F equal to FB, since it's a mass spectrometer, and you solve for V. And then from there, basically, the centripetal force is the magnetic force, and you just have to set those two forces equal to each other, since it's the same, and then you have to solve for R. So yeah, I feel like it was just, what made it challenging was having to think back to mechanics and like recognize that centripetal motion right there.